Hello, and thank you for inviting me to this great show, Space for Women show, and this important panel talking about the quantum technology and its impact on space security. So I'm Rania Toukebri, I'm a space engineer as well as space policy and strategy expert, and I'm the regional coordinator for Africa and SGC, which is the biggest network of students, professionals, institutions, as well as professionals in general, and it's among 150 countries. And our mission for my team and I is to build up space sector in Africa and to improve the capacities and to build up capacities and improve the conditions that are there. Today, we will talk about the quantum technology, and the first question that we should ask, why we do need quantum for space applications and for space security. So we all know that in the last years, we had a huge exponential number of cyber attacks, and we try to find out many solutions to solve this issue, and which is very important for the security of the state, of individuals, as well as for private sector. So, but you all know that it's more strategic and it's more crucial to support the state for this issue, because it will affect a lot the geopolitical power in the region and in the world. So when we try to think and to see how things were happening before for the classical communication, we will find out that these are based on classical laws of physics, and we were based on some complex mathematical algorithm. And we all know that it's more the algorithm are complex, more the security is assured. But we do have now more powerful hacking systems and sophisticated hacking systems and hacking technologies that were able to hack us, to hack the communication, to destroy the point-to-point communication, which made us very vulnerable to this kind of communication, to this kind of technology, sorry. So the quantum application appeared some time ago, but the biggest experience and the most important experience was with Mishu's satellite, Chinese satellite launched in 2016. And the purpose of the mission is basically to investigate space-based quantum communication for creation of the hack-proof communication network. So when we tried to think and to see how quantum was working, we were just refer to this picture you see over here about the classical bit and the qubit. So a classical bit and a normal bit can be in a state of a 0 or 1 at once, but a qubit can be a 0 and a 1 at the same time. This will give us an advantage to have a bigger number of probabilities for a certain number of bits and qubit, of course. And this is based, of course, on the quantum theory, which is saying that subatomic particles can act as they are in two places at once. And if this property is well manipulated, of course, this and the particle will not be observed, which is creating a state of superposition, we can create for sure like a communication that is based on a non-observed state of particles and non-observed basically message. The quantum communication in space, we had successful quantum encryption experiments, but we had, of course, some limitations. The limitations were basically made on the first thing, the medium used. So we were using it through optical fibers. And of course, using optical fibers, the signal can be observed, and then it won't be possible to make it for long distance. So they had the idea to create what we call the quantum repeaters that capture and retransmit the quantum information, which is a very good solution. And China also was using the solution by beaming entangled photons, which is related to quantum theory, through vacuum of space. So of course, they will not be observed. The Mishu's satellite was working in this way, and it's like basically by firing a laser through crystal, and which creates a couple or a pair of state of entanglement, and each pair would be sent to those two separate stations on Earth. And quantum theory says that they are both basically related and connected, whatever is distance. The objective of this mission was basically made to generate the communication keys encrypted with an assembly of entangled photons. And the informations, as you can see over here, it will be like over encoded, and set in a random number generated between the transmitter and the receiver, the two stations on Earth. Of course, in this way, the hacker that will try to interfere and to spy will it will not be very possible, because the information, the encrypted key, will be unreadable, and because of the observer effect of the quantum theory. And in this way, the transmitter will be able to change his message in all security. The impact of quantum on international policy. So here I just chose to mention two big power, politically and technologically speaking, which are China and USA, because these are two major countries that really can make a huge impact by their cooperation or their like competitions in this field. So we know that the quantum technology and the quantum communication will have a huge impact on the military technology used, and more the military sophistication will increase, and more this will have the power, the geopolitical power, and it will in consequence decrease the United States authority. China has already started the economical and technological development. And when we try to see on the other side that United States, because of their policy, they are declining their dominance in space and in technology in general. And this will create and make China a leader in quantum technology, and will create in consequence a multipolar power balance on international relations. But for sure, we all know that many countries are also trying to continue on this path of development of quantum technology, and they are trying to invest more in this technology. But we know that China and many countries in Europe are investing even more. And the question to be asked now is, who will be able to reach the frontier the first? The Chinese space program and the use of quantum technology, if we try to follow up a little bit things happening since 1970, we will see that everything has been studied, and there has been a very clear strategy since the beginning. So China has already started launching their satellites since 1970, which was a little bit delayed compared to United States, to Russia. But we know that the number of satellites is increasing since then. They have created their successfully their China space navigation satellite, which is Baidu, that is providing very precise geolocation, information for the Chinese weapon systems and communication coverage and its military, which is a very strength point on military and geopolitical aspects. And this, of course, will create the dominance in air and force. And quantum technology will improve and accelerate this process. China is aiming to launch their space station by 2022, or to start this space manned station, permanent manned space station, in 2022. But we also know that the ISS will stop their work by 2028. And this will make China, of course, the basic first reference for space research in the outer space, let's say. And China is also aiming to launch 35 satellites for this quantum technology, and will create the network of the use in quantum communication by the project called CAS, which is Quantum Experiment for Space State. And by 2030, this is the research that will also focus as well as artificial intelligence, as robotics as well. And this, of course, will determine the next generation for space, for defense, and for security. We have also very limitations, very cons of the quantum communication in space for now. So we know that the 2030 project for China is aiming to increase record distance between two stations on Earth. And technically, it's used by beam entangled photons between stations, and achieving, of course, by high level quality precision. But this is our ultimate objective, and we hope to reach it one day. But actually, there are some issues and some limitations to realize this experiment. The first thing is that the atmospheric interference and movement on ground, it will obscure their trajectory and it will delay the synchronization between the two stations. The second problem is that there might be some difficulties to minimize the attenuation for long distance. And if the entanglement occurred for real and the operation happened successfully, there will be some delay and some issues to make the rate of data transmission convenient and optimal. It will be a little bit, let's say, basic and just enough to make just very simple communications. The other issue is, which is a major one, which is we are basically using the classical communication, the classical computer processing, the classical communication, which will make the use of quantum communication a little bit exceptional and not very well used. And of course, for the communication for satellites and for the communication of the ground station, we will not have enough technology and enough tools to make this more spread around. Also, securing the global communication via quantum encryption, it will also, on the other side, reduce the vulnerability of the current communication infrastructure for hacking and interference. Also, we have also to think to improve a little bit the medium used and the technology used to make this quantum happen. And by this, maybe we can try to wait a little bit, maybe 50 years, if I may say, to make the technologies ready, to make people ready, and the policies as well ready to launch this new technology for securing data. There are also some big challenges related to the future for quantum technology. We don't know if this kind of communication will create a cooperation or a competition. And we know that the competition between two powers, it may create some non-peaceful uses of space products and some, we can maybe refer to some weapons and so on. The second thing is that if you are using a more secretive programs, that it can aim to gain more influence in space and Earth. So we don't know what are the intentions of the user of this kind of technology. Plus, this kind of technology, it needs and requires a huge investment over time. It's very expensive. So it may become a burden for countries to develop this technology. And so the idea is to maybe to make more countries focused on this technology and more countries collaborating on this technology, just to maybe divide the investment, if I may say, and to make it very strategical over time, and to, of course, to make everyone involved in it, even in Africa. It's all about ethics. It's all about why we do need to use such technologies. And it's all about trying to improve our daily life and trying to make technology used for us. And as we all may say, it's basically bringing space down to Earth. So that's all for today. And thank you for following up. And maybe see you soon.